Hello, Algebra 1. We're working in 8.2 quotients. To get started, we are looking at a quotient as a division of terms with exponents. Our properties say that when we have the same base, we can take our exponents and subtract. So to present this idea given, if we put it in fractional form, which we know the fraction bar is a division symbol, get this idea. Okay, right away, 32 divided by 4, that's 8. But look at the a cubed divided by a to the first power. In invisible math, that's an exponent of 1. When we're dividing the same base, we can subtract the exponents. Very simply put, 3 minus 1 is 2, so a to the second power. This would be our final solution, but let's expand the idea just so we can see it. If you like this idea, a times a times a over a would leave a to the second power. So we have that idea going on here with the property of the exponents being subtracted when there's a division of the base. So you can expand it if you would prefer to do that over subtracting. Okay, we have a presentation in the numerator and denominator here. We go through carefully and just look at all the parts. 24 divided by negative 8, that leaves a negative 3. X squared divided by x to the first power, 2 minus 1 is 1, so that leaves an x to the first power. Y to the 6th divided by y to the second is 6 minus 2, that's a y to the fourth power. Z to the 7th divided by z to the 5th, 7 minus 5 is 2. Z to the second power. I like a tick mark in the middle of my z, and it differentiates it from my 2. That's our final simplified presentation. Here we're working with negative exponents. We have x to the negative 4 times y squared. The negative exponent is equivalent to the reciprocal of that power with the positive exponent. What does that mean? If we put the x with the negative 4 exponent in the denominator, then down here we're going to say that would be like 1 over x to the positive 4th power. It's in the numerator originally. When we pop that base x into the denominator, the exponent goes positive, and vice versa. So what we have is y squared still left in the numerator, x to the 4th power in the denominator for our final presentation. So use the reciprocal of those negative exponents. We have another one here. So just to work in the margin over here, we're going to have x to the negative 2nd power. That's going to be equal to 1 over x to the positive 2nd power in the denominator. Okay, so that leaves 2 times 1 in the numerator. So we will have 2 in the numerator left, and the x goes to the positive 2 power in the denominator because we worked with the reciprocal. Okay, we're going to continue to work with a negative exponent, but we have parentheses involved. That cubed outside the parentheses means that term inside the parentheses is multiplied by itself 3 different times. So what this looks like, breaking it apart, would be negative 3 to the 3rd power in the numerator, but then x to the negative second power would be x squared in the positive in the denominator to the third power. When you have an exponent outside parentheses sets, your exponents or your base is multiplied by itself as many times as that exponent says. So, to start, we would have negative 3 times negative 3 times negative 3 in the numerator. But here, the property is that this 3 is multiplied by the exponent inside the parentheses set. So you have now x to the sixth power in the denominator, which all equals negative 3 times negative 3 is a positive 9, times a negative 3 is a negative 27 over x to the sixth power. Okay, we have more examples of this idea. All right, so what this looks like, breaking it apart, this negative 2 outside the parentheses applies to each term inside the parentheses again. And that looks like 1/3 to the negative second power times x to the negative third power all to the negative second power. Okay, so the reciprocal of 1/3 is 3. And that would be to the positive second power now. Because we took the reciprocal of the base, that makes our exponent positive. Look that over. And then because negative 2 is outside the parentheses set for x to the negative third power, our property is to multiply those. That becomes a positive 6. So we have 3 times 3 times x to the sixth power. That finally equals 9x to the sixth power. Look this one over. Check it out. Do some work with your negative exponents, also your parentheses, and what exponents are outside those parentheses. Okay, we have a presentation of division. If you rewrite this idea with a fraction bar, it helps you see numerator to denominator what you need. 34x to the negative third times y squared times e to the negative fifth all over negative 18 times x to the negative 6 times y squared times e to the negative second power. Okay, so right away you would have 34 over negative 18. And we're going to take our x's and take the reciprocal of both the numerator and denominator as the base x and make the exponents positive. So whatever's in the numerator is going to flip to the denominator and go positive. X to the negative third becomes x to the third power. X to the negative sixth power in the denominator goes to x to the positive sixth power in the numerator. All right, then we have y squared over y squared. What this leaves is y to the 0 power. And we do need to address that y to the 0 power shortly. So 2 minus 2 in the property of subtracting your exponents when you're dividing with the same base occurs there. Okay, we've got a c to the negative fifth power. That's going to go from the numerator to the denominator and the positive. And z in the denominator is a negative 2 is going to go to the numerator as a positive 2 when we use the reciprocal. So just carefully address each idea. All right. Now what happens is if you take a GCF of 34 and negative 18, that leaves a negative 17 ninths. To simplify that fraction, 6 minus 3 in the x's leaves an x to the third power. Any number or variable to the 0 power is equal to 1. Doesn't matter. 1,000,000 to the 0 power is equal to the value of 1. A variable to the 0 power is equal to 1. So what happens here is that y to the 0 power renames as times 1. So that makes everything easy. 2 minus 5, because we're dividing the same base and subtracting the exponents, becomes z to the negative third power here. Okay, so if all of that is true, we continue to simplify. We're going to have a negative 17 ninths times x to the third power all over z to the third power in the denominator. Because we're going to take that reciprocal and keep simplifying that z to present a positive exponent, which is the goal. I'm right at my smart keys, so I'm finding it difficult to write that z at the bottom and the 3. But it is z to the third power at the bottom. Okay. We're going to look at this example. Let's check it out. Remember, outside the parentheses, an exponent means that term is multiplied by itself as many times as it says. Carefully apply in multiplication your exponent to everything inside the parenthesis set. So if that is true, you're going to have y to the third power in the numerator over x squared times 3 in the denominator, which is 2 times 3 is 6, all times x to the third power times 2 in the next term is x to the 6th. And that 2 times negative 4 is y to the negative 8th power. Alright, so this renames as y cubed times x to the 6th power all over x to the 6th power over y to the positive 8th power. Look that over. And what happens is x to the 6th over x to the 6th cross cancels. 3 minus 8 is a negative 5. And you will have y to the negative 5th power for your final answer. We could write it 1 over y to the positive 5th power, but when we see this idea in the numerator in simplification, we know that that property will apply. I hope this helps, and I'll see you soon.